Hello, everyone. It is Thursday, August 10th, 2023, and we are going to have some fun tonight, just doing some live coding and hanging out. 2 nights streaming in 3 days. That is a lot for me, getting back into the swing of things. And we're going to take a look tonight at a data set that was just released by a website that I'm a big fan of called Kaggle, and that's a Kaggle website that hosts data science competitions. Let's see who's out there. Epic Shots out there. Thanks for watching right now. So let's take a look at this. This data set that was just released and maybe do some data exploration. What do you guys think? Hello, everyone. Sonic Gaming says, welcome to the stream. Yeah. Before we dive in any deeper, just a little bit of background about Kaggle and MetaKaggle. There is a MetaKaggle data set which exists out there. And this has, like, if you imagine on a website like Reddit or, I don't know, Twitter, where they don't necessarily give you, especially recently, they're not giving you access to APIs so you can access and do analysis of data. Kaggle's kind of the opposite way when it comes to all the different code that's created and the competitions and the notebooks that are made. They release that data publicly because they know that the people who are interested in the site like looking at data. So they're going to share it to everyone. Kaggle versus GitHub, which one is better? They're two very different things. So I think you need if you want to get into data science, you need to know Kaggle stuff, but really GitHub, anyone who writes code should know how to push their code to GitHub. Not everyone needs to know about Kaggle unless they're doing data science-y stuff, I'd say. But yeah, so there's this MetaKaggle data set that has like everything that people have done on the site. So I had fun with this. Where do I see it? My work. So I had fun with this, like doing analysis of past leaderboards in competitions on Kaggle. But I also, this I made, how long ago was it? 5 years ago. I made this notebook, and here, let me put on the dark mode for people. I made this notebook where we found someone who was making multiple accounts and then downvoting everything that a handful of us who were calling them out. What I found was this one person was posting things in places where they shouldn't. People politely asked that person to stop. And we all found that anyone who asked that person to stop, we'd get like massive amounts of downvotes. Our comments would be like -6 downvotes almost immediately. So using MetaKaggle, I was able to look at all the users, the kernels made by this one person, and see some trends in the data, like who was voting on this person's kernels, or notebooks they're now called. And sort of did some triangulation to identifying that there were a handful of people or accounts that were all following and liking what this one person did. And they were probably associated with all these downvotes. So once we took a closer look, Kaggle versus bagel, someone says, Zao. That's hilarious. Definitely, it depends on the time of day. In the morning, you might want a bagel. So it turned out that this person was being upvoted by a bunch of accounts. And then when when I took a closer look at the names, we noticed that a lot of them were made on the same day. And they had names like Tim Cook, Steve Jobs, Esprin, L. Page, Bill Gates. Man. So this person was being very creative when they made their fake accounts, to the extent that it made it easier to identify that they were fake or that they were associated with each other. And I think these accounts are still existing They're still existing. Sonetta Gaming, thank you for subscribing on Twitch. I'm going to go ahead and spin this wheel for you. I spin the wheel every time we get a new subscriber, and Sonetta Gaming, thank you for doing that. Oh, and you're going to get... am I going to scream? Nope. Sign to the mic for you. Thank you so much for subscribing on Twitch. If you guys aren't following me on Twitch, you should go there now. Let me get this link and put this in the chat. Need to sleep. Can't wait to watch the VOD. Okay, cool. Yeah, go to bed. Okay, so that's the Meta Kaggle data set that I used 5 years ago to do that analysis. Now they've released this Meta Kaggle code, which is kind of takes it a step further than just releasing who created notebooks and who placed in which position on competitions. Meta Kaggle code, they've actually assembled all of the code that's publicly available under Apache 2.0 license from Kaggle into one spot. So I guess this saves you from having to scrape all of Kaggle. Now, one interesting thing I want to look into, maybe once we get deeper into this, is how does this compare to maybe something like StarCoder? We looked at StarCoder on the stream not too long ago, and StarCoder is a large language model that was trained on this publicly available code data set. And it's supposed to do auto-completion similar to, what's it called? Copilot with VS Code, right? And this was scraped all from GitHub, but I don't think it has any of the Kaggle data. So I'm wondering how this compares to this Kaggle data set, both in size and in quality of it. So yeah, I was just taking a quick look at this data set, and I don't know, it looks like there wasn't that much code when I'm just clicking around here, but it's hard to get a good idea of what it has. And I know this is a decent data set because it was used to train that StarCoder LLM, which we used on stream, and it was pretty good for being completely open source. Just for transparency's sake, what is my current salary? Also, I'm subscribing on Twitch. Thanks for subscribing on Twitch. My current salary is between 100,000 and $1 million. It's somewhere in between there. I think that's what Nick Wan's response is whenever he's asked that question. Something like that. It's in that range, between like $25 a year and like 25 million. So joining with Metakaggle, explore public notebook content. Metakaggle is an extension of Metakaggle code is an extension of the popular Metakaggle dataset. This extension contains all the raw source code from public notebook versions on Kaggle. The IPyNB, that's IPython notebook files in this dataset generally do not contain the output cells. Okay, so it's just like the input code, not necessarily. A lot of it's going to be visualizations and stuff on the output end. So we're just looking at the code coming in. Joining with Metakaggle, this file contains a subset of the kernel versions in Metakaggle. Okay, so I think every time you create a notebook on Kaggle, it's given a unique kernel version, which could be joined with this. So you could go in and see which of the files are associated with which user and when it was created, all that information. But this data set, if I understand it correctly, is just the code itself. The file names match IDs, whereas Metakaggle contains data for all interactive and commit sessions. Metakaggle code contains only data for commit sessions. Hold on a second. What does that mean? Whereas Metakaggle contains data for all interactive and commit sessions. Okay, so I think this makes sense. it'll be easier to show. So let's create a new notebook on Kaggle. And we're going to add MetaKaggle and MetaKaggle code. Now, when you save this version, or right now, what I am in is an interactive session. So it's starting up here in the top right. Well, it won't start until... All right, so now this draft session is initializing. So when you save this version, you can save and run all, which is a commit, or you can do a quick save, and that'll save it the way it currently looks. I think that's an interactive session. I'm not quite sure. I mean, I think what I would call this is the interactive session right now. Like this currently is an interactive session. So I don't know how it would change every time that technically I just changed this, right? So this is different code. So I don't think it would ever save that as a new version. I think only if you save this and not commit. So it won't actually run the code when you do the quick save. Okay, so file organization. The files are organized into 2-level directory structure. Each top level contains a folder of 1 million, excuse me, 1 million files. Example, folder 123 contains all versions from 123 million to 123999999. Each subfolder contains 1,000 files. 1,000 files. In practice, each folder will have many fewer than 1,000 files due to private and interactive sessions. Oh, those pesky private and interactive sessions. We love feedback. Okay, let's take a look. So there was someone who made a pretty cool notebook, which it's hard to tell with this dark theme on if I've upvoted it. I have. Where they went through some of these IPy notebook files, and they split out just the imports. They looked for where it said import and saved that off and did some analysis of that, which we could do. There's also this person who made a notebook that shows how to join it with the MetaKaggle code file name. So how did they do it? They'll probably just do some join, right? Kernel by ID, return kernel's loc ID. What? Okay. Okay, so they're just saying like in this kernel's CSV file in the MetaKaggle dataset, there's an ID column, and that should link with those millions of files that are in each folder. Need some water? LOL. Yes, I do. Yes, I do. Rex Riker, you're right. Would you say watching these streams are a good way to learn, gain insight into data science projects? I don't know. Llama-like. I'm sorry I got so offended by that. No, that's a good question. I really don't know though, because I'm not watching them. What do the other people in the chat think? I think it should just be more fun. We don't always have to learn. Sometimes we can just have fun. That is a lot. What is a lot? I only learned how to shout millions. Yeah, you're learning that, which is very important. When you get that high-paying data science job and your boss asks you how many files there are in a folder and it's 1 million, you have to scream it. If you don't, you'll get fired on the spot. I mean, what are they paying you for if you're not going to scream 1 million files? What really is Kaggle? Please. Kaggle is just the data associated with what's going on Kaggle. So the Kaggle has, like, every competition has an ID and they give you that. It's basically like, the way I would think about it is every website has this data in their back end, but they don't usually just put it out there for everyone to see. They usually, if you work for a company, you probably have worked with an SQL database that would have all this data. And as an employee, you might write SQL queries on it and do joins, and your website itself might query from it, but they're actually just putting it out there for everyone to use, right? That's what the Kaggle is. It's the data's data. Yeah, Rex. Rex knows what's up. All right. So here's the gist. Here's the deal. This is not a small data set. As I mentioned, it has over 1 million files in one folder. Actually, up to 1 million files, probably less because of the private and interactive sessions. But regardless, it's about 134 gigabytes of data. So, and the other thing is, it's not like 134 gigabytes of image data or something where each file is large. It's 134 gigabytes of data where each file is tiny, like bytes. Look at these R files. Let's just go to one of the last million of, like, this notebook. Oh, geez. My bad. Look, see, I even broke this website by looking there. Data card. We're just going to explore this data down here. Over there. All right, I clicked on it again. 29 kilobytes. So let's actually do some exploration. So I like to use exclamation point and ls will let you run bash commands in this interactive environment. I think this is going to be meta, dash Kaggle code. Oh yeah, this needs to be ls-l. That'll list this directory like this. Okay, so let's do ls-l and let's pick one of these random folders, 041. Then we see that there's a folder within here. There's folders within here with up to 1,000 notebooks, but this does not have 1,000 notebooks. It has 856 notebooks here. We also see that the file extensions that are in here are, some of them are Py files, but most of them are IPython notebook files. Just like this interactive session that I'm running right now, most of the stuff's going to be notebooks. Hi, Rob. How much data points do you think from your experience is enough for fine tuning on text classification? Can you give a range under 50,000? Enough? I think it really depends, Anish. I don't really have a good feeling for. It really depends on what you're trying to classify, right? So if you're trying to classify something that's easy to classify, like if the sentence is a question or not, then you wouldn't maybe need that much data. But if you are trying to classify something that's more specific, you would need more data. So it's kind of hard to say. I know that for fine-tuning LLMs, the order of like thousands is fine. Like 10,000 is, I think, a lot for fine-tuning, but not for, that's assuming that you have a foundational model. That's pretty good. GZT is in the chat and says, what's up? Honestly, question mark? Wiley, what are you talking about? And then we open a notebook, and this is a notebook we are running. Yes. What if this was the notebook we are running? Oh, it'd be like the infinite loop. Okay, so if we also look at, let's look at the very first folder, because I noticed something interesting about this. It looked like the very first folder was mostly R code. Look at this. Everything in data science started out as R. And then it turned into, and look, most of these are also, or there's a lot more public ones than there was before. So let's just do a head on this. That'll give us the first 5. So these are all R, and these are example files from subdirectories. I don't know why I'm saying that. Okay. So let's say we want to read this R file. We can we can concatenate it. We can output it by doing this. And then instead of ls, we can cat this first one. Let's see what the very first notebook on Kaggle was. It was hello SDS world. Whoa. And we're catting a cat. This is really deep stuff. Now, if we cat this IPython notebook, which was, I guess these dates aren't very legit. But let's look here. If we cat this IPython notebook, we're going to probably see it's in, JSON. So this is not as easy to read because it's IPython notebooks actually store all the code that's run in JSON format. Make sense? R, those heathens. Yeah, Rex. Web scraping stream when? Oh, we're kind of doing web scraping right now. We just have the scraping done for us. Can we do a head on this? We kind of can't do a head on this because it's just like one big JSON. But let's comment that out and let's look at one that is a Python file because that's going to be a little bit cleaner to read. Yeah, so it's kind of cool that up here it says oh, I thought it was going to say the username and all that stuff, but it doesn't. So this is example Python code. It's like a example code on how to use a Kaggle notebook. All right, so how do we do analysis on this? Can pipe to JQ? Can pipe to JQ? I don't know. And then, oh yeah, okay. So how are we going to read in, let's just do some meta-analysis. Meta-analysis of files and sizes, I guess, question mark. I don't, the thing is with this many gigabytes of data, we are going to probably not run our analysis on everything right now. We'll just test it out on a few files. And then we can have it run in the background later. But let's go into this input directory. Meta Kaggle code. So it's going to be like this. The stars are going to represent wildcards. See, how long is this going to load? All right, and 0, 0, 0, there are no IPython notebooks probably because everything was R back then. Let's go to this 041 just to see if this is working. Oh, it's because I didn't put a star here. Yeah, there probably were notebooks in the first one. All right, so it took a little while to run on that, but we do have, I'll put it here, a string list of all the files. So is this going to take too long to run on that? No, I think it'll be okay. So we could, while that's running, also do R and do Python files. Maybe this is going to take forever. Because, okay, that ran in a few seconds for one folder. How many folders are there in this data set? How do I even get to it? $110 more. So probably like 150. What do you guys think? This is so fun, right? I'm about to stop this because who would want to do this? Maybe we just do all of our testing on one of the subfolders. So we landed on this 041. And, okay, so yeah, so we're just doing this on one of the subfolders, which can have up to 1 million files. 1 million. All right, so there are 3 types of files I believe that we could find. IPython notebook files, R files, and .py files. And we're only going to do this in one of the subfolders. But we can actually find out how many subfolders there are if we would up this. So this is the number of So there are the length of this subfolders, number folders. Gotta run that. There are 140 folders. Test out on one subfolder for time. And we're doing this on subfolder 0041. And let's do the length of the IPython notebook files. Yeah, let's just do this. This many IPython notebook files, this many R files, and this many Python files in this folder. I'm going to assume it's really heavily weighted. Wait, this is R. This is Py. Wait, so there are no R files in this. Maybe we should choose a different directory then. So let's make this subdir actually a string. And let's go into this bad boy and make this something we can manipulate. Gotta manipulate it. That 1 million screen was really funny, caught me off guard. That is a lot of folders. It's actually the number of files within a folder, but yeah, you get the picture. It's a lot. I use PyTorch to optimize models. Yeah. This is not where you would apply that. Okay, so what are we doing? This is a subdir. Subdir. Let's see if we can hit a folder that has some R files in it. Why is this one taking so much longer? No R files. Jeez. This hates us. Got it. I've been trying to learn to build simulation models with SymPy. Do you ever build simulation models with SymPy or optimization models with Pulp? I haven't. Me, personally, no. Xcode, I haven't. I missed that comment earlier. That makes the other comment make a little more sense. All right, so we're just not finding any folders, many folders with IPython notebook files. But we could see that. So let's actually see how long this would take to. So actually from TQDM notebook, we'll import TQDM. And let's see if we're going to loop through. If we're going to loop through all of these subfolders. And then do this. How long would this take? There are 140 of them. And it's taking about 1.6 seconds for each folder. But also the first folder is going to be kind of quick. Because these numbers, I think, are going to get larger. Maybe they're not. Oh, maybe it's also not going in numerical order. But this would take about 4 minutes just to run through the subfolders and to count how many files there are. We're actually opening any files here. And you could see already how long this would take. So yeah, we're not gonna do this. But we are gonna just choose this one subdirectory, which is 055, and let's try to load in a list of the. Oh, we have this list of IPython notebook files. So let's look at let's start with IPython. Looking at the IPython notebook file. So if we do this, we can just take the first one and we're going to have to use JSON, and JSON loads. With F as open, and then we'll open this file, right? I need this the other way. With open. There we go. All right, so now we have, so what does this do? This opens this first IPython notebook file, which is, let's say, testing on file, and that's this. So we've opened this up, and we always want to use open like this with a with statement in Python, so that as soon as this code is done executing, it releases that file. So you could do F equals this open stuff, but it could potentially leave this file open on your system forever and lock it out and cause issues. So we like to use the with statement to load in the data. And then you can see when we use JSON, we load in the type of JSON as a Python dictionary. Okay, so now we have a Python dictionary. Oh, look. Oh, look, we just landed on the University of Liverpool ion switching tutorial. The University of Liverpool ion switching competition is the one where I got a solo gold in this competition 3 years ago. There were over 2,500 teams, and I landed in 11th place. I actually was like first or second almost the whole competition. Well, at the top for most of the competition, and there was a little bit of a shakeup, and I went down to 11th. And these top two people actually found a leak in the data, so they cheated a little bit. What a coincidence, yeah. So that's kind of fun to land on that. Small r, not capital. That's why it's 0. Oh, that is, see, that's why I do this on stream. So you guys know what's up. I should have second thought why we were always finding 0 R files. It seemed like I knew R was rare, but not that rare. Okay, so this has 11 R files. Thank you, Mohammed, for mentioning that. Tangential question from last Google competition. Does your own GPU help with competitions just to help testing your ideas? Of course, yeah, having my own GPU helps a lot. But for the actual competition, the model has to be generated from their GPU? No, that's Edward. So you can do everything with your GPU. You can train your model. Well, usually there are some competitions where you have to do everything end to end. Those are super rare. Most of them, because Kaggle knows that it costs a lot of resources to run all this training time and all the experimentation people want to do on their own machine. You can train offline, then you upload your model weights. So that's like transferring what you've learned on your local computer or a cloud computer, wherever you train it, or on a Kaggle kernel. And then you put that as a Kaggle dataset and use that to predict on the test set. So you do use their GPU usually, but just for inference. Or that's the only thing you have to use it for. Hope that makes sense. All right, so what are the keys on this? Also, what is this music we're listening to? Jeez, so repetitive. Can you guys even hear the music? Because I sure can. Where is my notebook? Okay, here it is. All right, so very low. Okay. It's probably actually better that way. All right, so in these, I think the notebooks are all pretty much the same. So let's just say that this is the notebook keys. And let's check. Let's check to see if all these files for IPython notebook file in IPython notebook files. And then we will do this again. So we'll read them all. Except this is going to be IPython notebook file. We're going to wrap this in TQDM so we have a progress bar. And then we'll assert that the data keys equals this notebook keys, what we think it is. All right, so we don't have to wait the full minute for this to run all the way through. But all we did here was just check to make sure, at least in this folder, all the notebook files have these same keys. So I could actually make this do break after 1000, and let's do enumerate. All right, so now it'll just go to 1000 and stop here once it reaches it. But we know that all the notebooks have these keys. And let's look at the notebook keys. Cells, metadata, NB format, and NB format minor. Okay, what's NB format? NB format is like how it renders, if I'm understanding this correctly. It's, all right, so it says IPython notebook files are simple JSON documents containing text, source code, media output. Each segment is a cell, okay. All right, so that's just like handling the schema of what these files are, I guess. I don't know how to explain it. But let's look and see what each of these are. So let's take this one example we have. If we go to cells, cells are like what we're in right now. Is a cell, right? So this notebook, let's take the length of the cells, and there are 45 cells in it. If we take the first one, all right, so maybe we need to organize what our understanding of this is. We're using a cell to understand how the cells are formatted. All right, so we have cells. That looks like it's the code and metadata for the notebook. Again, a very weird song, which I'm going to switch off of. All right, so what else do these have? So this is like a unique ID for the cell GUID trusted. So that's just metadata. I'd say most of the time we're going to ignore the metadata. So it always has metadata, it looks like. And then also source, which is the actual code or text for the cell. Is it always like that? Okay, then there's also execution count. I don't know if execution count's going to have anything for these committed ones. Like you could see here on this cell of code, I could run it many, many times. And this number on the left is just going to start going up and up. So it's at 76 now, 77, 78. So I'm assuming that's where it would store this data. And then the outputs that they said they did not keep, right? Also cell type. Oh, good point. Good point there. Thanks for keeping me honest. So we can try to figure out what the cell types are. It's either going to be code or text, right? Cell type markdown for this one. Okay, so it might not. It looks like maybe it doesn't have an execution count or outputs. So this is actually going to be a cell type is code or mark down. All right, then we have our outputs. Let's test this hypothesis. Let's test this hypothesis that every data cells. So we'll loop through each of these cells. And we'll print the keys, just the keys. All right, so we could see that there are metadata, cell type, source, and then some of them have execution count and outputs. Let's even test this another level deeper. Look how deep we're going. All right, so we'll loop through 50 notebook files. We'll loop through 50 of these. I guess I could just do this. That's probably a lot easier than enumerating. Right? Then we don't have to have this ugly stuff. And then we'll want to assert let's just print cell keys. Let's just see how long it takes to do all these. All right, we can visually see that they're all either going to include these 3 keys or 5, depending on if they're code or if they're text. All right, that's easy enough. You guys get it? All right. So what else is in this data? That's just cells. What's metadata? All right. This just looks like it's going to be kernel specific and language info. So I guess kernel specs and language info. So this is going to be like the Python version, I'm guessing. So let's first look at kernel spec. As a language display name. Okay, so kernel spec actually has a version of Python. And then language info, what that going to be? Okay, so there's more specific of which version. All right, that's fine. So that's kind of like doing this. I thought you could do print Python info sys. I thought it was like sys version, sys version. That's what I was trying to get. Yeah, so this tells us like we're in Python 3.10 right now. And this is packaged by, this even gives us the date and the GCC version that was used to compile it. Man, that's nice. Kernel spec, I think, is the name of the kernel, not the Python version. The name of the kernel. So you're saying that this notebook that we happen to land on just happened to be the 50th notebook here. The actual name of the notebook is Python? I don't think so. Dude, no way. No shot. Try to be cool by saying no shot. Because look at this. Yeah, it's basically saying, is it Python or is it R? Right? So we just went through 50 different notebooks, and we see that so actually a IPython notebook, a IPYNB, can be an R IPNB. Does that make sense? So just because it's IPNB, IPYNB extension, it could still have R code in it. No shot, Mr. Gen Z. Yeah, I'm hip. I'm cool with the young kids. No shot. John Power knows what's up. All right, so I think I'm saying kernel spec is the Python or R version info, language info, more detailed info about the language. And let's stop on one of these where the kernel spec, if this language equals display name equals R, we're going to break on that. All right, so we stopped at the first R notebook, and we look at this data. We see that it has the same cells. It has the metadata. And then the language info is stuff like the version of R that we're running. What is the latest version of R? 4.3.1. So when this notebook was released, they were using old school 3.6.3. No shot. No shot. They were using 3.6.3. Let's put the sys stuff at the top. I'm just going to start saying no shot all the time just because I think it's funny. All right, we're almost through this NB format. This is going to just be some junk. NB format is just a number. Oh. So that's just like the version of NB format that it's running. This is 4.9. I bet they're all going to be from the same folder. They're all going to be the same version. Let's just loop through a bunch of these. Yeah, let's, instead of breaking what I did before, let's go through here and print these NB format. They're all going to be 4. Come on. Yes, they're all 4. And then, oh, NB format minor is just going to be like the minor version number. So maybe these will change, but they're all going to probably be the same. So that's just telling you like the version of how Jupyter renders the notebook. So if they had any major changes to how they render the notebook, it would be in the new NB format version. That makes sense? That makes sense? So what do we care about? Let's look into the code. All right, what if we tried to take a bunch of these files? All right, so let's think about this. Let's make a function called load IPNY. That'll just load this JSON data, so we don't have to write that over and over again. I guess we could just return this, right? And then let's make a parse function that'll take this and let's just call it, I should delete this. Let's just call it extract code. And that takes in the data and it should return the code. So what we'll want to do is go into the cells. And for each cell in the cells, we're going to look and see if it's code. I guess it's not going to be that efficient if we do that. But here, if that cell type equals code. So we'll do this. If this is code, we'll call this codes. We're going to append this. Not with the cell type though, but with the actual data from it. Or the actual code from it, which is called source. And then we're going to return the codes. All right. So now if we do extract code from this data, we should get a list of just the code cells. There we go. The beautiful, beautiful code. And let's just take one of the cells, one of the interesting cells. Are any of these interesting? They're all kind of short and sweet. But if we print it, then we can see it rendered correctly because it has these new line characters. If we like opened up something like Sublime and just pasted it here, we could see format. This is Python. We could see that it looks like normal code, right? Like this is what we're extracting from this JSON. I wish we could find a cell that had something more interesting. This is about as interesting as it's going to get. Ooh, that went really big, really fast. What did you say? With open file in the function, not the IP notebook file? Oh, good point. Thank you. Thank you. You caught it. So now if I do load yeah, there we go. Let's pick a happy sound mix and round this out. Okay, what are we going to do with this now that we have it? We can extract code. We can we can extract, can make a whole new function that's called extract markdown. So if we say extract markdown, now we have the text. we have just a list of the text. But let's only load all the code from the entire 1 million potentially folder. All right, let's see if we can do it. Let's actually undo what I just deleted. So let's go through all these files and see if we can extract all the code from 18,000. Rick's Riker has a redeemed hydrate. Jupyter Notebook has an AI assistant. For a moment, I thought that was Java bytecode. No, not bytecode. What is this AI assistant? Jupyter AI brings generative artificial intelligence to Jupyter Notebooks. Just what we need. Giving users the power to explain and generate code, fix errors, summarize content, ask questions about their local files, and generate entire notebooks for natural language prompts. When did this come out? August 2nd? Oh, it's way out of date then. It's like a week old. I'm just kidding, by the way. Using its powerful magic commands and chat interface, Jupyter AI connects Jupyter with large language models from all these different sources. All right, let's see it in action. What? Wait. Jupyter Not? Hi there. I'm Jupyter Not, your programming assistant. Come on, it's like Clippy. Are they bringing Clippy to Jupyter? See, here's the thing I don't understand. It's basically like you have another tab open when you're coding and you're just Googling stuff. You're just searching for it. Is it better to have it as an AI assistant? Maybe. If you're slow at switching tabs, I guess. It just would need to be really good to be valuable, I think. It'd actually need to work better than Googling. All right, enough of that. That's interesting, though. Thanks for mentioning that. I didn't know that was even out there. Are there Copilot that suggests while you write is much nicer than? Yeah, I do really like Copilot. One thing I really like when I'm using Copilot is if I'm doing something stupid like, I'm trying to think of an example. Like if x equals 5, print blah, this is 5. If x equals 2, print this. Like if you're doing this with Copilot, should I bring it up? Let's see if it could complete that. This is something new. That's something different. Ignore all this. This may or may not be the code that I'm using in a Kaggle competition currently. But let's just say this. Okay, so let's pretend this is Python. Does it know it's Python? All right, so how would it... print this? See, it knows the tab completion for that is awesome. And then it's even trying to guess what the next one is. And a lot of times when you're typing something with Copilot, that, like, if we were doing this with 1, this is a stupid example, clearly, but it knows if x equals 3, print this is 3. And let's just actually say, let's pretend like we're actually screaming it now. This is 1. this is 2. Then Copilot will know if x equals 3, print this uppercase. And like this little stuff saves actually a lot of time with Copilot, I find. And it's because, and see the stuff like this that's not necessary, but I guess it's not bad. But I guess my point is that this actually saves time because you're not clicking away to something to search. It's actually just helping you complete what you want to complete, but better than you would ever imagine. Like more detailed and picking up on the nuances of how your structure of your code previously was, right? Google's new IDX is better. Man, it's so hard to keep track of all this stuff too. Like every day there's a new thing. Okay, so for file and IPython notebook files, we're going to load the file. Then we're going to extract the code. Right? We're going to store it in a dictionary called results. Where the key will be the file name and then the codes will be here. I don't know if this is, let's see what the results looks like. Maybe we actually just want the file name. So we'll split on this and we'll take the last. So this will be like the file number. We'll store it like this. That's, now, should we make that an integer? Is that better? Because then it's not. All right, so let's see how long this will take to get all the codes. I want to hear what you guys think, though. Do you guys use code completer things? Clippy was ahead of its time. All Microsoft Word users didn't understand how important it was that they were writing a memo for upper management. Edward, why are you making that face? Edward Chen. Are you sad or are you happy? Oh, because you were the one suggesting talk about Copilot. I agree. Yeah. But what's this? Okay, while this is loading, let's look up Google IDX. What is this? 1 day ago announced. Introducing Project IDX, experiment to improve full stack multi-platform app development. All right, let's see what this looks like. idx.google.com. I have no idea what I'm looking at. Has the full capabilities of a Linux-based VM paired with universal access, comes being hosted in the cloud with the data center near you. Can I go to idx.google.com? Project IDX is currently limited preview. Join waitlist. What the freak? What if your dev experience was, ugh. I want to join the waitlist. My name, Rob. I accept all these agreements. Join. Success. Stay tuned for updates. Okay, I'll probably just forget about it. Did this complete? Yes. So results now has, oh shoot, I shouldn't have done that. Shouldn't have done that. All right, let's do the length of results. It should be the same as this. So 18,000. Why did I do it again? Results for this number. So what can we do? Can we find like the most out of these 18,000? What's the most common? Yeah, maybe we don't want to store the results like this. Let's just make a long list of all the code. So I just add the new codes, and I have all codes, and the length of this. All right, so now we're getting somewhere. Almost 500,000 code cells. What if I make this a Panda series and I just do value counts on this? All right, this is what I expected. So what are we doing here? I made a Panda series with all of the code from these, however long it was. 460,000 cells. And I did a value count on this. So this means count how many exactly identical cells there are in all of these cells. So this one example occurs 13,000 times. And let's see what that is. It's this one. I don't know why I'm doing it this way. Why does it show nothing here? Oh, because the most common one, say I was just getting screwed up. So the most common cell is actually just nothing. Like you don't even see it here, but it's an empty cell. That's the one that occurs 13,000. Less common is this next line of code, which is the generic code that comes equipped in every notebook when you start it up. This is how you know if you're a total noob making a notebook, is when you go to it and you see this text there. So if I go into here, index 1, that's this. And if we print this, yeah, so this is like that example that starts with every new notebook. And then this is the second most common, which is not generic, but it just happens a lot, and that's df.head. I bet this is the most, yeah, other than the generic intro to the notebook. That's interesting. I never would have thought this. I guess if I had to think about it for a while, I would have thought of it, but that df.head is the most common cell of code that you would find in a notebook on Kaggle. Right? So it has over 1,000. So that means that 1,000 out of this length of all codes. Yeah. So 0.2% which is actually 0.002 of all code cells are df.head. It's still a lot. It's 1336. What's 1336? Oh, shoot. I accidentally just clicked on something in our chat. Oh, shoot. I accidentally did something. Armbloth. If you're in the chat, I clicked on something and accidentally blocked you. It says here. Let me do this. Pop out chat. What am I doing? Where did it go? Oh, now it doesn't show it. It says I accidentally blocked this person. I didn't mean to. Please come back. Don't hate me. Don't hate me. Hey, by the way, speaking of this chat that I messed up, we're at 4,975 followers on Twitch. Almost at that 5,000 mark. Look at that right below me. There's that thing filling up. It's almost hit 5,000. Almost there. Tell 25 of your friends to check it out. All right. So let's save this notebook. And let's make it public. We didn't get too far tonight, but we're doing it for fun. We're just learning as we go. We're asking questions. We're talking. You timed me out. Oh yeah, I'm sorry. It was Mohammed. I'm sorry. He said so in the YouTube chat. That was a total misfire on me, misclick. You can tell that I'm not that coordinated with my mouse. All right, I'm going to make this public. I'm going to save it. We're going to go to this notebook, and I'm going to put it in the chat. I can't still see your message. Oh, yeah. All right, so that's in there. Man, that's the notebook. I just linked it. You can click on it and see the notebook. You can fork it and start doing your own analysis from there. You could run it on all of the code and then just make one long list of just code. That would maybe be a fun Parquet file to have, which is just the code stripped out of everything else. So you could do some analysis of that. Maybe train a large language model on it. I don't know. You could do so many things. If you're not already following me on YouTube, we just hit 100,000 subscribers last month. I got my silver play button coming in the mail. It said it was going to come today. Then I got a delay message from UPS saying it's going to come on Monday. So we got to wait for that, but I'm going to open it on stream for sure. I put the link to my YouTube channel if you're not already checking that out. Then I also streaming right now on Twitch, which I'm going to put into the chat. You can watch me there. Always watch there. It's a fun way to watch. Then there's also Twitter, or I guess if it's called X now, whatever it's called. You can follow me on that. I'm going to put that in the chat. And then, of course, you want to join our Discord if you haven't already. The link is now in the chat. Congrats again on that YouTube milestone. Thanks, Rex. It was fun to get there, and I look forward to making some more content here soon. I've been kind of slacking, but we're gonna get back into it. So, yeah, that's all I had tonight. Let's make sure that this notebook actually saved. Show it to you guys. Yep. So it did run. You guys can follow along if you want. You can fork this and take a look at some of the code. Yeah, give it an upvote if you want. Then it will be in the Meta Kaggle dataset that you upvoted my notebook. And then I'll track you down. No, just kidding. All right, so I'm going to go ahead and raid somebody on Twitch. if there is anyone coding. Let's go ahead and raid the Primogen. All right. A lot of energy going into the Primogen. He's a guy who streams code and he has a humongous following. So we just need to piggyback off of him. Yeah, you know, just like everything on the internet. There he is. Going to go to raid channel. Click on him. Start raid. He's playing some video game that I don't know. Let's just try to get on his radar. All right. See you guys. Bye. Bye. See you, YouTube.